Good morning, students. Today we will have a discussion there on the combinational circuits, that is half adder and the full adder. So let me discuss first of all what are half adders. Half adder is a combinational logic circuit which are basically used to add two single bit numbers. These circuits utilizes two inputs and generates two outputs. Like in this diagram, block diagram, it is shown here there are two inputs A and B, results into two outputs sum and carry. So when these two inputs A and B could be a combination of 0 0 0 1 1 0 and 1 1. Now next one is how we can design half adders. There are some fundamental steps that we follow for designing an half adder. Now this half adder is basically, as with the previous slides we came to know that it requires two inputs A and B, which will generate two outputs sum and carry. So we have to basically identify in the step 1 what will be the input variables, हमारे input variables क्या होंगे, and what will be the output variables. So depending upon the input variables A and B, we will have the four possibilities. First input A 0, second input B 0. Then the second combination will be 0 1 1 0, and the last final combination will be 1 1. So depending upon these four inputs, we will compute the outputs, that is sum and carry. So this is the flow chart. This is the truth table basically that shows a complete description about those four input combination, and with respect to these four input combinations we are having two outputs, that is sum and carry. So this truth table is very easy one. You can read it out, like when both the inputs are 0 0, then we will have the sum and carry 0 0. When one of the input is 1, other one is 0, like in the second row it is 0 and 1, then we will have carry 0 with sum value 1. Similarly, in the third row, when A is 1, B is 0, the carry will be 0 and the sum value will be 1. Similarly, in the fourth row, when both the inputs are 1 1, the carry will be 1 and the sum will be 0. So this is a very simple truth table that can be utilized there in the working of half adder. So the next step is basically to use the expressions. What will be the Boolean expressions for these half adder working? So you can see here we can simply use an XOR function between the two inputs. So the sum will be the Boolean expression for the sum will be A XORed with second input, that is B, and the carry will be calculated, will be computed using an odd operation between an AND operation between A and B. So C will be equal to A dot B. So these are the two expressions that always we use, therefore carrying out the addition of two single bit numbers using half adder. Now the step number 4 is, what will be the logic diagram of this half adder? Now you can see here, as we have the expressions that is for both the outputs, that is sum and carry. Sum is basically calculated using an XOR implementation between the two inputs. So we are having two inputs. You can see here we are having two inputs that we have identified in the step number 1, that is A and B, and depending upon these two inputs A and B, we are having the outputs, that is sum and carry. So following this truth table and following this expression, we can draw the logic diagram. So there is a complete XORing that is basically taking place between the two inputs A and B. So we can see the expression of the sum, it is implemented logically using XOR gate, and the second one is how to represent the carry. Now the carry will be represented by ANDing or by performing an AND operation between the two inputs A and B. So you can see here from this logic diagram, the implementation of half adder just only involves the use of one XOR gate and one AND gate. So let me repeat it out. We are basically studying here the combinational circuits. The combinational circuits, they are basically the very simple combinational circuit is half adder. Now this half adder basically adds two single bit numbers. It has two inputs and two outputs. The block diagram of this half adder is shown here. With two inputs, we are having two outputs. Similarly, in the step for the designing purpose, we use following steps. The step 1, just identify the input and output variables. Depending upon input or output variables, we draw the truth table. Then step 3, we write the expression. And in the coming exercise, we will definitely let you know how to solve these expressions using, or how to use K-maps even. But for the time purpose, we just remember these two expressions. S is equal to A XOR with B, and the carry is equal to A dot B. A dot B mean that it is the AND operation that is basically taking place there. The fourth step is how to make the logic diagram, how to represent the basic working of half adder using the gates or using the logic diagram. So in this diagram you can see we are using two gates, one XOR gate and one AND gate. The XOR gate is basically is meant for calculating the sum expression, and AND gate is basically used for calculating carry. So let me brief it out what we have studied so far. We have discussed the half adder. Now there is some shortcoming, or there is some problem that is there with the half adder. The half adder have no scope of adding the carry bit resulting from the addition of previous bits. To overcome that problem, to overcome that drawback, we are having the another combinational circuit, that is the full adder. Now full adder basically it is again a combinational logic circuit. Rather than using two inputs, it is used for the purpose of adding two single bit numbers but with a carry. So full adder has the ability to perform addition of now 3 bits. With half adder we were having the addition with the 2 bits, but with full adder we can have the addition of 3 bits. So full adder contains 3 inputs and 2 outputs. Similarly, just like the half adder, we will have 2 outputs, sum and carry. So what is the basic difference what we got from these two circuits? Half adder utilizes 2 inputs, generates 2 outputs. Full adder utilizes 3 inputs and generates 2 outputs, just like half adder, that is sum and carry. So this is the block diagram which is shown here. So there are 3 inputs. First one is A, just like the previous half adder scenario, B and C input. C input basically it is the input that is from the previous bits. The next is about the designing one. How to design the full adders. Now full adder basically it is just like the half adder. It can be designed in the various steps or using the various steps there. Now step number 1 is again just like the half adder, we have to identify the input variables and the output variables. So input variables, there are 3 input variables, A, B and C. C input. I am just taking a third variable which is basically represented here with C in. So values of these 3 input variables will be either 0 or 1. And similarly, depending upon these 3 input variables, we will have 2 output variables, that is sum and carry. Now step number 2. What will the truth table for this full adder? So with 3 inputs, A, B and C input, we will have the computation of 2 outputs, that is C out and sum. So you can see with 3 inputs we will have 8 combinations that will start from 0, 0, 0. Look at the first row, 0, 0, 0. The value of A is 0, B is 0 and value of C in is 0. For that, the carry will be 0 and the sum will be 0. Similarly, for row number 2, you can read out the complete table row by row. For row number 2, the value of A is, first input is 0, the value of second input is 0, and the value of third input, that is C in, is 1. And depending upon these three input fed to the system, we are having two outputs, that is carry and the sum. Now this carry will be 0 and sum will be 1 for this input combination. तो जब आप रो नंबर 3 की ओर प्रोसीड करेंगे, when we will proceed with the row number 3, it will be A is equal to 0, B is equal to 1, and C will input when we will take it as 0. So we will have the sum, that is carry is equal to 0 and sum is equal to 1. So this is the the truth table for all 8 possibilities for 3 inputs. The next one is Boolean expression. Just like I'm just skipping this K-map procedure here, but I just want to make you people clear that what will the Boolean expression for this sum and the carry. Earlier there were 2 inputs, but now we are having 3 inputs. In half adder, we were carrying out the XOR between 2 inputs, XOR operation, exclusive OR operation. Now here in full adder, we are having an operation, XOR operation, but with 3 inputs. Similarly, we can calculate the Boolean expression, or we can calculate the output, that is carry, with this expression, that is C out is equal to AB. AB mean an AND operation between the 2 inputs A and B, followed by an OR operation between again B, C in. B, C in mean a AND operation between B input and the C input. Similarly, we can have the third part. So this is the complete Boolean expressions which are shown here for both the sum as well as for the carry. Now the last step, especially just like the half adder, what will be the implementation? How the implementation, or what will be the logic diagram? The logic diagram of full adder basically here in this picture shows 1 XOR, 3 AND and 1 OR gate. So you can see here we 3 inputs. Look at here, C out. If I have to calculate C out here, now you just see here C out is calculated using this Boolean expression, and when we observe this Boolean expression, the expression starts with AB, but mean there is a AND operation between 2 inputs AB. So you can see the first AND gate, second AND gate and third AND gate, they are meant for calculating AB, BC in, C in A. Once the AND operation between these expressions are calculated, then we perform the OR gate. OR mean AB plus BC in plus C in A. So this is how the C, that is the carry, is calculated in full ladder. And for calculating the sum, as per this expression, it is an exclusive OR between the three inputs A, B and C in. So three inputs are XORed, which are shown here in the slide. It is a complete logic diagram for full adder, showing up the implementation using one XOR gate, 3 AND gate and 1 OR gate. Thank you. If any query, then you can ask.